In case of the Thevenin theorem, the current flowing through the load resistance or load impedance is given by this expression. That is, IL is equal to VTH divided by RTH plus RL, or VTH divided by ZTH plus ZL, where VTH is Thevenin's equivalent voltage calculated at the output terminus when the load resistance or load impedance is removed, either or, and ZTH or RTH is the Thevenin's equivalent impedance or resistance calculated at the output terminal when the load resistance or load impedance is removed and all sources are replaced by the respective internal resistances or internal impedances, whatever. So this is the statement. Now I will try to discuss what is the statement related to this, or the statement of the Thevenin theorem, that we will try to understand. How is the VTH and how is the RTH? Then here always Thevenin's theorem problems can be solved by using the 4 steps. I will discuss about the steps only. How is the VTH, how is the ZTH, that I will discuss. Step number 1 is remove the load resistance or load impedance and redraw the same circuit. This is the first step. Means whatever the given is circuit, remove that resistance or remove that inductance or remove that impedance in which the current is asked. तो जिसमें करंट पूछा है उसी को रिमूव करना. Suppose in this case it is RL. In that case, how will be the circuit if I am using the step number 1? If I am using the step number 1, circuit will be something like this. Just in the step number 1, remove the load resistance or impedance and redraw the same circuit. This will be the circuit. This is right. This will be the circuit. This is R4. This is R5. Here it is R2. This is R1. And this is R3, and this is applied voltage, which is V. Just I am copying the same thing, just this load resistance is removed. This is step number 1. How is the step number 2? The step number 2 is the calculation of VTH. Just concentrate, no need to write anything. I will repeat the same thing once again. Calculation of VTH. Now look at what is the VTH, or what is the definition of the VTH. VTH is the Thevenin's equivalent voltage calculated at the output terminals when the load resistance is removed. Now, these are the output terminals. This is A or this is B, AB terminal. Now, our aim is to find out the voltage at this point whenever the load resistance is removed. Already in the step number 1, we have removed the load resistance or load impedance. Now, find out the voltage here. How to find out the voltage here? Now voltage travel from the B towards A. Means if we are finding this VTH, Thevenin's voltage, we are traveling from the B towards A. This voltage across R5 plus voltage across R2 plus voltage across R4 is the VTH. Means we are traveling from the B towards A. This path. Use any path. We can use this path also. But generally we will use the shortest path, which will have minimum calculations. Now here we have to find out this voltage and this voltage, then we are in a position to find out its VTH. That is Thevenin's equivalent voltage, right? Now for that calculation purpose, we have to find out current in all these elements. Now look at how much is the current in this R5? 0, because it is open circuit. How much is the current in R4? Again 0, it is open circuit. Now, we are interested in the calculation of current in R2. How to calculate this? Use any method. Maybe the mesh analysis, nodal analysis, maybe the simple KVL, KCL, or anything other method, you know. In this case, the simple method is that this is one loop, assume its current as I, mark the polarity, and apply the KVL to this circuit and find out its current, that is I first. If we know the I, then we are in a position to find out this VTH. This voltage is 0 because current in R5 is 0. VR2, its current, we can calculate this value, which is I into its resistance, that is I into R2. And finally, the voltage across this R4 is again 0 because this is open circuit. In this way, we are able to find out the VTH. This is the step number 2. Try to understand carefully. Then we will use the step number 3. What is the step number 3? We will calculate the value of RTH or ZTH. If it is a pure resistive circuit, generally it is RTH. If it is an impedance circuit with inductor and capacitor, in that case, that value is impedance. This we are interested in the calculation of RTH or ZTH. Here, all the resistances are there. That's why I will call it as RTH. This is RTH. How is this calculation? Now look at, I will read out its definition. Thevenin's equivalent impedance or resistance calculated at the output terminals. कहाँ पे calculate करना है? Output terminals पे, A, B पे. When output terminals, when the load resistance is removed, this has to be removed. This RL has to be removed. Load resistance is removed and all sources are replaced by respective internal resistances. Because if we have the sources, then we are not able to find out the series or parallel combination. Which in that case, we have to remove the sources by internal resistances. Means, if it is a voltage source, that should be replaced by zero resistance. If it is a current source, that should be replaced by the infinite internal resistance. Means what we want here, we want to draw the new circuit by removing the load resistance and by removing all the sources. Means if we are drawing the figure for the calculation of RTH, in that particular case, this figure will be something like this. Is it right? It will be something like this. Here is A terminal, this is B terminal. We have removed the load resistance, we have removed the sources. This is R1, this may be the R3, this may be the R2, this is R4, and this will be the R5. Then these two resistances are in series combination is parallel is in series, and means we are able to find out this RTH. Means we can find out this RTH, this is the step number 3. And if we know the value of RTH, then what? Then this complicated network is replaced by the simple network, which is known as the Thevenin's equivalent network. It is similar to the voltage source. This value is the RTH, which we have calculated here. This value is the VTH, which we have calculated here. And reconnect the load resistance, which is removed in the first step. Load resistance or impedance, whatever it may be. This is RL. And now find out its current, IL, load current. Now it is very simple circuit. What is the formula for the load current? Formula for the load current is total voltage divided by total impedance. Total voltage is VL, and total impedance or resistance is RTH plus RL. And this is the statement whatever we have defined in step number 1. This IL is equal to VTH divided by RTH plus RL here. This is VTH divided by RTH plus RL, and it is came from this particular equation. Or if these are the impedances, in case of the impedance, how will be the circuit? Circuit will be something like this. This is right. This will be the load impedance. This will be the load, source impedance ZS, and this is VTH, or this is ZTH to be exact. Here, this IL is equal to, this is VTH divided by ZTH plus ZL. This is the equation. And this is the explanation. Yes, I will use the similar part in the explanation. Step number 1, step number 2, and so on. Is it right? These are the basic things which we have tried to understand here. I will discuss with you. I will unmute to all of you one by one, and I will discuss the difficulty level in this case, and then I will take the explanation part related to this. Avinash, any difficulty?
No, sir.
No. Chaya?
Yes, sir.
Any difficulty?
No, sir.
No. Rishikesh?
Yes, sir.
Any difficulty in understanding these 4 steps?
Yes, sir. Understand all. I understand.
Okay. Then Saurabh?
Yes, sir.
Any difficulty?
No, sir.
No.
All clear.
Yeah. Here in this case, if anyone is there, then please raise your hand. I will start the discussion of the explanation part. This is right. Now here in this case, I have taken this particular figure for understanding the explanation of this theorem, which is nothing but the Thevenin's theorem. Is it right? Now I will use the steps. I will use the steps. Now here in this case, what is the step number 1? I will use the steps. This is right. Step 1. Now you can write with me. Step number 1. What is the step number 1? Remove the load resistance and redraw the same circuit. Remove load resistance and redraw the same circuit. This is right. If we are removing the load resistance and redrawing the same circuit, how will be the figure? Figure will be something like this. We are not doing anything. We are removing the load resistance. This is the step number 1. Now, our circuit as per the step number 1 will be something like this. This is A terminal. This is B terminal. Just we have removed this load resistance. Which is the load resistance? This resistance में current पूछा है. That resistance is nothing but the load resistance. The resistance in which current is asked is the load resistance. This is the step number 1. No need to use any mind in the step number 1. Just remove the load resistance and copy it. Now, step number 2. I will draw. Step number 2. Step number 2 is the calculation of Thevenin's voltage. Calculation of Thevenin's voltage. That's right. How is the calculation of the Thevenin's voltage? For the calculation of the Thevenin's voltage, we have to find out current in all these branches which are involved in the calculation of VTH. If I am using the formula for VTH, अगर VTH के लिए मैं formula use कर रहा हूँ ये, this VTH is equal to, we are traveling from the B to A always. We have to travel from the lower to higher. If we are traveling for this case B to A, this voltage plus this voltage plus this voltage means VR5 plus VR2 plus VR4. Means we have to find out voltage in this and this resistance. For that, we need to calculate current in all these 3 resistances. Current in this resistance is 0. Current in this resistance is 0 because there is no path for the current. Is it right? That's why current in these branches will be 0. Now here, means indirectly we have to find out current in this branch which is R2. R2 में current निकालना है. For that case, I will assume its current as I because we have only one closed path. And we will apply the KVL to this figure and we will find out its value. Now how will be the path? In this case or in this calculation, what I am writing, applying the KVL to first loop, we get. So we are applying the KVL to the first loop. If we are applying the KVL to this loop, how will be the equation? We are starting from this point. We are traveling in clockwise direction. We are traveling in the clockwise. Negative to positive, that is a I into R1 is its potential. Then positive to negative minus. It is I into R2 is its potential. Then positive to negative, that is minus. Is I into R3 is its potential, which is equal to 0. This is the application of the KVL. We are interested in what? We are interested in the calculation of current, which is I. इस figure में हमारा interest क्या है? Our interest is to calculate. Our interest is to calculate its value of the current, which is I. How to calculate the I will separate out the terms. I will shift all these terms on the next side and I will take I as a common. Then it will be R1 plus R2 plus it is R3. This is right. Now here in this case, if it is the circuit, then how is the calculation? This I is equal to V upon R1 plus R2 plus R3. If the values of the voltages and currents are given, we are in a position to find out its value of the current, which is something amperes. This is the calculation of I. If we know the I, then we are in a position to find out its VTH. That is Thevenin's equivalent voltage. How is the VTH? This VTH is equal to, we are traveling from the B towards A. How much is the voltage across this VR phi? Otherwise, I will write. It is always, I am taking it as modulus value or positive value. This is VR5. Is it right? Because this value, we are traveling upward, negative to positive, that is a plus. VR2. Then no polarity for this, means it is a plus VR2. Which is equal to this value 0 plus VR2. How is the VR2? It's I into R2, means this is I into R2. Plus this value is 0. Is this VTH is equal to, it is modulus, I into R2 will be the value of VTH. Will be the value of VTH. Now here in the step number 2, we have calculated its value of the VTH, that is the Thevenin's voltage. Now we will use the step number 3 and we will try to find out its value of the RTH. How is the step number 3? I will discuss here. The step number 3. We will discuss about the step number 3. I will start here the discussion. This is the original circuit in which we are trying to understand its explanation part. Yeah. Now I will discuss about the step number 3. Here, step 3. What is the step 3? Calculation of RTH or ZTH. Is it right? Now look at the definition of the RTH or ZTH. It is a Thevenin's equivalent impedance or resistance calculated at the output terminals when the load resistance is removed or load impedance is removed and all sources are replaced by their respective internal resistances. In this case, we have to remove the load resistance and all sources. Here is the voltage source. We will remove that source by its internal resistance, which is 0. Then we will draw the figure as it is. At the same time, we will remove the load resistance. Here is A terminal and this is another terminal, which is B. This value is R4, this is R2, this value is R5, this is R1 and this is R3, and we have removed the load resistance also. Now in this case, if we have this particular circuit, now we will try to find out its RTH. How is the calculation of RTH? In this case, now look at these two resistances are not in the parallel combination, क्योंकि जो CAE1 हुआ उसमें कुछ बच्चों ने इसको parallel combination लिया है. It is not in the parallel combination. These two resistances are in series combination. This is next figure will be something like this. Is it right? This is A. This will be point B, and here will be some resistance. Is it right? This is R2, this is R4, this is R5. This resistance I will call it as RS. That is series combination, which is R1 plus R3. Is it right? Now this RS is parallel with the R2. I will call it as RP. This is A. And this terminal is the B. This is R4, this is R5, this is RP. And how much is the RP? RP is this RS and R2 are parallel. RS into R2 divided by it is RS plus R2 will be that value. Is it right? Now, if we know both values or all the values, then how is the RTH? Now look at it. This RTH is equal to series combination of all. Means it is R4 plus it is RP plus R5. This is the value of RTH, that is Thevenin's equivalent resistance. Is it right? And if we know the value of in this case, if we know the value of RTH, then step number 4. step number 4. What is the step number 4? If we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. Is it right? Whenever we know the VTH and RTH, because in the previous step we have calculated the value of VTH. Here we have calculated the value of VTH. Here we have calculated the value of RTH. If both are known, then complicated network is replaced by Thevenin's equivalent network, and this simple figure is known as Thevenin's equivalent network. This is RTH, what we have calculated. This is VTH, and here we will reconnect the load resistance which is removed into step number 1, and here we will try to find out its load current, that is IL, and as per this figure, this IL is equal to VTH divided by RTH plus RL, and this is the explanation part of this particular theorem, which is nothing but the Thevenin's theorem. This is the explanation part for this theorem, which is the Thevenin's theorem.